polynomials, radicals, logarithms. That's algebra number 2. Let's get out of here. So starting off algebra 2 with numerical solutions and symbolic solutions. So numerical solutions is when we have some kind of equation where we're trying to find a specific value. And symbolic solutions is when we're trying to use a general expression to solve an equation. So starting this off, I'm going to go ahead and use simpy, import, and I'll use symbol, equation, and solve. Now, simpy is probably not installed by default, so you just want to make sure that you're in your virtual environment, and you can go ahead and do pip install simpy like that, and that will get that module installed for you on that virtual environment. So for this one, we can grab like an X symbol, we can enter a Y symbol, and create our equation, which is x to the power of 2 times y. And our solution is going to be solve equation times x. And now we can display the solution by printing it out. So solutions to x to the power of 2 equals y. So for sol in solutions, print, we'll do an f string for x and passing in the solution that we've created. So if we run this and press play, we can see that x equals square root of y. So if we replace y with, let's say, 10, then we'll see x equals the square root of 10. And we can create custom polynomial evaluations as well. If we want to evaluate a polynomial for a specific value, we can do so evaluate, eval poly stands for evaluate polynomials. It's just a function I'm making for myself. And for this, we gotta pass in the coefficients and some sort of variable. So we'll do result equals 0, and we could do xp equals 1. For a and coefficients, result is gonna add 1 to a times xp, and xp is going to multiply. So this is pretty much saying that xp is the same as x to the power of p, and we can return the result. And here we can pretty much run this by passing in the coefficient values that we want. So I can create an array of 1, 2, 3, and these are the coefficients of the polynomial. So it would be 1 plus 2x plus 3x to the power of 2. And if I were to change this to 5, then this would be 5 as well. So that's kind of how that equation looks like on paper. And we got x value equals 2, and the result can be eval poly to evaluate our polynomials, and we'll pass in our coefficients and our x value. It doesn't like my comment here. Oh, because I forgot to put the x in. There you go. Oh, and then here I could just print, make an f statement. So I'll just pass in the result. So this equation here equals to 17. And if we were to change these around to 8, 12, 53 or something, and we change the x value to 5, we get that number. If we change this back to 1, we get that number. And from there we can look at factorization. So we can factorize quadratic polynomials using quadratic formulas. So for that, again, we can use the simpy module and import symbol, equation, and solve. And we can do quad fact for quadratic factor. And here we can pass in a couple placeholders for our numbers. And we'll pass in this x symbol using our simpy module. And we could do equation, EQ. Our equation is going to be a times x to the power of 2 plus b times x plus c, and we'll pass in a 0. So our solutions is going to be solve equation with x. And our factors, this is going to be to display the factor form. So our factor form is going to be x take away the solution for sol in solutions. And we're going to do a factored expression. And we'll use the multiplication to join our factors together. So instead of splitting it by the multiplication sign, we're going to join them together. And then in order to run this, we can pass in our factors here. So our factors here would be like x to the power of 2, take away 5x plus 6. And we can just print out. And it's not printing it out because we need to add a print statement here to show our factored form, show our factored expression. And now we can see our factored form is x take away 2 times x take away 3. And if we actually want to pass in some numbers, then we can replace, here we can do a, b, c, and put in our values. So it could be 1, 2, 3, let's say. And here it factorizes the quadratics that we've passed in to this array set. Now let's move on to polynomial division. So we'll use the same module again from SIMPy. Define our quadratic factor function. And we'll start it off the same kind of way. Put in 3 placeholder numbers. And pass in that symbol again for the x. So with polynomial division, we can just use numpy's module. They just have a numpy.polydivision specifically for this, so we could just do, let's say, so our first one is going to be the numerator polynomial. So we'll pass in a couple numbers. You know, this is our numerator polynomial. So our equation would look like sort of like this. And I'll do den poly for denominator polynomial. We'll pass in a few more numbers here. I'll add my note in. And then we'll do QV for quotient value equals QV. Just a little variable I'm creating. And then remainder value I'm going to set as RV. So RV like that. And we'll just run this NP poly division. And I'll pass in numerator polynomial and my denominator polynomial. And now all I have to do is print it out. And I'll type in the quotient is QV. And the remainder is the remaining value. So if I were to run these, we can see that these are our polynomials for our numerators. And these are our denominators that we're dividing by. So we're dividing these numbers by these numbers. So this number here is if we had this and we were dividing this by this. So by dividing that we get 2.5 and our remainder is minus 4.5 and 3. So now let's get over to rational exponents. So rational exponents represent fractional powers. So for example, if we have x to the power of a half, let's say, that means we're taking so with rational exponents, it's like, you see this x right here, like this x, and there's like a 1 with an n underneath it. So let's say this 1 is a 2 and the n is a 3, like just for the example. So the way this would be is like x to the power of 2/3 pretty much. So this means we take the cube root of x and we square the result of it. And the way we can do that is importing the math module. And we're going to create a function that transforms rational exponents into radicals. So with that, we have to pass in a base, a numerator, and a denominator. And here we can calculate the value using rational exponents, with the value equals the base to the power of the numerator divided by the denominator. So going back to our little value here, we had x to the power of 2 with a division and a 3. So this is like a fraction, right? So just like here, we have a little fraction with the 1 over the n. Here we have an m over the n. So if we were to do that same thing, it would be like a 1 and an n. Now this one would be this, and then the denominator would be the n, and then the base would be the x. So again, the x is the base, the 1 is the numerator, the n is the denominator. Next, we calculate the radical form. And our radical value is going to be the base to the power of our numerator divided by our denominator. And our radical expression is going to be base to the power of denominator to the power of numerator. And now we can print out our values with these f strings where the rational exponent is base to the power of our numerator divided by our denominator. And then we can print out our value as a extended float, and we could print out our radical forms. So that's going to be the radical expression equals the radical value. And lastly, we can pass in all of our numbers. So far we have base, numerator, denominator, but we haven't actually set any numbers to it yet. So in the end here, we can package it all together. So our rat exponent is going to be, we could put in whatever numbers we want. Let's say our base is 10, and our numerator is 2, and our denominator is 3. So this would look like 10 to the power of 2/3. And here we can see that of this equation, our radical exponent is 10 to the power of 2/3. And our value is 4.6416, and our radical form is this big number right here. So that is showing the full equation and the value itself. So next, let's talk about exponential models. So we can use this to perform regression. If you've ever heard about the term machine learning oftentimes creates data, or it imports in data that already exists. Then it visualizes the data. So it creates some sort of relationship between the data to make out what it is. And then it's going to be using some sort of logarithm to then take some calculated guesses of what it thinks, take some calculated predictions. So here we can create some sort of fit exponential regression model. We're going to use a natural logarithm of y as the response variable and x as the predictor variable. So we're going to use the numpy as np, and we're going to be using the matplot library. And our step 1 is to create a data set. So x, these are our response variables. So np array, we can just pass in whatever numbers we want here. And then y equals np array 5, 6, 7, 8, 9, 10, 11, 12, 13. So our x is a response variable, and the Sorry, the y is the response variable and the x is the predictor value. So our response is going up by 5 every time. So this is kind of the data set that we're hoping it can catch the pattern and continue it onwards. So now we're just creating some plots for we're gonna do a scatter chart with the x label, a y label, title, and then the step 3 is to fit the exponential regression model. So we'll do fit numpy polyfit x np log and 1. And these are going to be our coefficients. And we can print out exponential regression equation is y equals np exponent times np exponent a to the power of x. And here we can create an example prediction. So x value equals, let's say 10. Predicted y equals np exponent b times np exponent a times x value. So now we're going to predict y for x equals x value and predicted y. So if I were to run this, so it looks like I have a poor data set. So I'm just going to grab the data set. So I'm just going to grab this data set that I found on statology.org. And now if I run this, now we can see the predicted growth. So it looks like however I put it in, it just didn't like it. Maybe we can revisit this for a future video so I can create a better data set. But otherwise, feeding in someone else's data set is good enough for now. So lastly, we can finish this video off by talking about logarithms. So logarithms, so the 3 ones we're going to talk about is natural logarithms, where we can calculate by using the import math module. And it's pretty simple, the syntax. All you do is natural logarithm of 2 is math.log2. And this little 2-word thing with a number in it, that's all you need to calculate natural logarithms. So if I were to run play, we can see the natural logarithm of 2 is this number. Let me clear out this terminal. And if we want to calculate a logarithm with a specific base, we can do print logarithm base 10 of 15. So we'll do math.log10 and we'll pass 15 into parentheses. And we can do another one where the logarithm base 2 of 20 and math log 2, and we'll pass 20 in there. And lastly, to calculate logarithm with the custom base, you can use this formula to print. You could do print logarithm base 4 of 20, and we could just pass in the math function to log 20 of 4. And here's the logarithm base 4 of 20. It's 2.16 and all these other numbers. So that's all for Algebra 2. I'd like to thank you guys for watching.